Hi, I'm Figment, and today we're going to do a very simple tutorial on sound effects, or on a specific sound effect. In a lot of old arcade games, Pac-Man, Defender, Joust, Galaga, even old kind of 8-bit consoles and 16-bit consoles, were using a lot of real simple waves, square waves, sine waves, a triangle wave. Um, So they all kind of sounded in the same realm of synthesis, if you will. Of course, there was different types of modulations and LFOs and stuff that were mixed in with those waves to get the whole range of different sounds that came out of those old games. But essentially, they were all really simple waves. So today, I'm going to show you guys how to make a really easy sound effect. It's kind of a jump sound effect, if you will. Makes me think about maybe Sonic the Hedgehog. Um, but anyway, let's just jump right into this and get going. The whole point of this tutorial, like I said, or maybe I didn't say it, but is thinking about reason a bit differently. Yes, it's can be you can use synthesizers in a musical context, but you can also use them to make in an abstract context, in a sound effect context, space explosions, stuff like that. All those old video games we know, or at least are semi-familiar with, were using synthesizers to create all the sounds from not just the music, but also the game sound effects itself. Okay, so in order to make this sound, all the stuff you're going to have inside of Reason, there's no extra um, rack extensions you're going to need, so no biggie there. So I'm going to create a subtractor, initialize the patch. We're going to make a square wave for the first oscillator. Change the filter frequency to about 90, 91, 90. You can leave the res alone. The amp envelope you're going to punch all the way up as far as the decay and sustain are concerned. Let's actually pull that down. Maybe you can leave it. I don't know. Not pull down. The filter envelope, you're going to bring the attack to 24. You're going to bring the decay to 64. The sustain on 0. And the release on 40. And you're going to raise the amount to 20. Okay. You're going to take that filter envelope to its 0 position and raise your amp amount to 20, 23, I guess. You can do 20, 21, 22. Play around a bit. And you're going to want to put your low bandwidth button on. Now it's kind of tricky making this sound because there's the way I'm remembering it in my head, there's a lot of, it can be done a few different ways. It can be done with, broken up into two parts, if you will, where there's an initial quick attack, and then you could have a bend afterwards, and in that case you'd probably have to use two different subtractors. I'm gonna go for a method of combining a Thor with this. So we only use one subtractor, one essential sound source. But the reason I'm using a Thor is because I'm only going to use its LFO, and you have one here. Actually, I didn't even realize that you can actually use LFO2 as a delay on it. Jeez. Well, I'm just gonna roll through it anyway. Jeez, I forgot LFO2 as a delay. Well, I guess you don't really need the Thor now, do you? Okay. So just clear out that Thor. Just not gonna use anything. You're pretty much just gonna use LFO2. Can you see the hertz though? Yeah, see then there's the there's the I guess you want to use the Thor. This is totally off the cuff. I'm thinking out loud because um, I think this is gonna always be synced. I think this is always gonna be like or no, it'll be free rate. But even so, we can't see the hertz, so my numbers will be off for you because you're gonna set the hertz to 0.53, 57. My mistake. 0.57. That's important. You're gonna set your delay to 63 milliseconds and sine wave. Yep, that's it. Okay, and just punch that LFO2 into the oscillator pitch and bring this down to 38, the modulation input. Okay, and that is basically right. You're gonna need a note. You're gonna need a note. I want this to be shorter. Alright, so you're gonna punch in a note that's gonna be F3. So F3, and give it a length of 0.0.3.0. That's the length that I found that works for me. And then just for some extra bitted fun, go ahead and take the output of your subtractor, punch it into a screen, initialize that patch, set it to digital. You can pull that damage control down a bit. I'm going to bring it down to about 42. You can leave parameter 1 alone and just bring parameter 2 up to about 100, 105, 106, 107. I'm going to use 107. And I believe, if I'm not mistaken, that is it. Very simple. You can take the mix knob and bring it over all the way to the left if you want, because we're not using oscillator 2. I mean, oscillator 2 is not even on, so this is silent. It's not going to make much of a difference. It'll just make it a bit louder. That's up to you. I'm going to leave mine in the middle, but you can if you want more drive, as opposed to raising the master level up. But outside of that, you should get something that sounds kind of like this. That's not right. What did I do wrong here? What did I do wrong here? Keysync? There you go. Make sure your keysync is on. Yep. And there you have a Sonic the Hedgehog type jump sound. It's a pitch bend with a bit of a delay in the beginning for this beep sound. But kind of cool, huh? Now that's just one example. Between the noise oscillator and all the other parameters of the subtractor, you can make everything from spaceship explosions, laser beam sounds, I mean, you name it. The Pac-Man munch 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 sound. Pretty cool stuff. Old arcade games were pretty cool. Chiptune's pretty cool. And there's a little something for your brain on making sound effects, bitted chiptune-esque sound effects with a subtractor and a Scream 4. So go out there, guys, and have some fun. And I'll talk to you later.